Hi students, and welcome to this very first chapter, which is progressions. Now there are basically three types of progressions that we are going to study in detail. These are the arithmetic progressions, the geometric progressions, and the harmonic progressions. So we have divided this entire chapter on progressions into four parts. The first covers the arithmetic progressions, the second is all about geometric progressions, the third is about harmonic progressions, and the fourth is all about the arithmetic, geometric, and harmonic means. In this very first lecture, we are going to study about arithmetic progressions. Here we are going to study what do we mean by an arithmetic progression, what is the general term of such a sequence, then how to find the sum of n terms of an AP. Also, we are going to solve a few problems that will help us to understand all these concepts more clearly. So, let's begin with this very first lecture, which is all about the progressions and arithmetic progressions. In this entire chapter, we are going to study about the different kinds of progressions. But before we go into these different types of progressions, first let's try to understand the meaning of progressions. What do we mean by progressions? Progression, as the name indicates, refers to the act of progressing, that is moving from one element to the next. So, if we have a sequence or a series in which we have got a number of terms or we have got number of elements, then the act of progressing or the movement from one element to the other is known as progression. For example, if we have a sequence S in which these are the terms, it has got n terms x1, x2, x3, x4, x5 and so on up to xn, then the act of progressing from one element to the other is known as progression. So we are progressing or moving from one element to the other. So it's possible that these series have some pattern. That is, the elements follow a definite rule. So first of all, let's see what do we mean by pattern over here. Now in our daily lives, we see so many patterns. Like if we look at the honeycomb, then it has got a pattern, it follows a rule. If we look at a pineapple, then we see this spiral follows a particular pattern. Similarly, if we look at a sunflower, you can clearly see that the petals follow a pattern or a rule, and even the grains of a maize cob follow a pattern. So these are some of the examples of things that follow a pattern in our daily life. Let's see one more example, the number of squares. So let us say that this is a square. Number of squares is equal to 1 here, 1 square equal to 1. Similarly, this is a square in which we see 4 smaller squares. So the number of squares here is 2 square, which is equal to 4. Similarly, if we look at this square, then we see that there are in all 1, 2, 3, 4, 5, 6, 7, 8, 9. There are in all 9 squares in this big square. So this is equal to 3 square. So we see here that even these squares follow a pattern or a rule. So these are some of the examples of things or events that follow a pattern or follow a particular rule. Now, how do we move from one element to the next? Is there a rule by which we can tell the given current element and the previous ones in the sequence? What is the next element? Now, if we say that we have a series or a sequence, now is there any rule by which we can tell the current element and the previous element? Also, can we tell the next element? Now, if we have a rule or a pattern, then we can easily tell the next element or the previous element. But what is that rule? This is something we are going to study under the progressions. So we can say that if we have a sequence, then there are two choices. Either this sequence could follow a fixed pattern or the sequence could not have a fixed pattern. If the sequence follows a fixed pattern, then such a sequence is known as progressions. So progressions are sequence in which the terms or the elements follow a fixed pattern or a fixed rule. Now, what are the different types of progressions? We have just seen what is a progression, but there are different types of progressions, and these progressions are the arithmetic progressions, geometric progressions, and the harmonic progressions. So these are the three major types of progressions that we are going to study in this chapter: the arithmetic progressions, the geometric progressions, and the harmonic progressions. So one by one we are going to see all these three types of progressions. The first is the arithmetic progressions. Now what are arithmetic progressions? Let us say that we have a series 1, 2, 3, 4, 5, 6 are the elements of the series. Now what we observe, the difference between these two terms is equal to 1. The difference between these two terms is equal to 1. The difference between these two terms is also equal to 1. The difference between these two terms is equal to 1. And so we can say that the difference between the consecutive terms is constant. And this difference here in this case is equal to 1. So this is an example of an arithmetic progression. This sequence 1, 2, 3, 4, 5, 6 and so on is an example of an arithmetic progression. Similarly, let's see one more example. If we have a series 1, 4, 7, 10, 13, 16. Now again, if we look at the difference between these two consecutive terms, then this is equal to 3. Also, the difference between these two terms is equal to 3. The difference between these two terms is equal to 3. The difference between these two terms is equal to 3. And the difference between these two terms is also equal to 3. Again, we can say that the difference here is constant and that is equal to 3. So this is also an example of an arithmetic progression. Now we have seen the two examples of arithmetic progressions. But now let's look at proper definition of an arithmetic progression. So what do we mean by an arithmetic progression? So we can say that an arithmetic progression, or AP short form, is a sequence in which the difference between any term and its just preceding term is constant throughout. This constant is called the common difference of the AP. So we can define AP as a sequence in which the difference between any term and its just preceding term is constant. This constant difference is called as the common difference of the AP. Now, let us say that we have an AP in which A1, A2, A3, A4 and so on up to AN represents the n terms of this AP. Now, the difference between A1 and A2 would be equal to D. The difference between A3 and A2 would be equal to D. The difference between A4 and A3 is equal to D. And so here D is the common difference. We can say that the first term here is A1. The common difference here is equal to D. And the nth term is given by AN. So this is an AP in which the first term is A1, common difference is equal to D, and the nth term is given by AN. Now let's see the formula how to find out the nth term of any AP. So once again, let's take an AP in which the terms are A1, A2, A3, A4 and so on up to AN. Now let us say that A1, which is the first term, is equal to A, and the common difference, that is the difference between the consecutive terms, is equal to D. So here A2 minus A1 would be equal to D. This comes from the definition of an AP. So A2 would be equal to A1 plus D. Now A1 is equal to A and the common difference is D. So A2 would be equal to A plus D. Similarly, A3 minus A2 would also be equal to D. So A3 would be equal to A2 plus D. Now we know the value of A2, which is A plus D. And when we put this value over here, what we get is A3 equal to A plus 2D. Similarly, let's try to calculate the value of A4. Also A4 minus A3 is equal to D. From this we get A4 equal to A3 plus D. And we know the value of A3, which is A plus D. Therefore A4 would be equal to A plus 3D. Thus from all these, what we can conclude is that AN, or the nth term, is equal to A plus n minus 1 into D. Here A is the first term, n is the number of terms, and D is the common difference. So the nth term of an AP is given by A plus n minus 1 into D.